This is section 5.2, Solving by Graphing. Our objective today is I can find solutions, which are also called roots, zeros, and x-intercepts, to a quadratic function by graphing. Quadratic equations are quadratic functions that are set equal to a value. The standard form of a quadratic equation is ax squared plus bx plus c equals 0, where a cannot equal 0 and a, b, and c are integers. The solutions of a quadratic equation are also called roots, zeros, and x-intercepts. In example 1, we're going to be graphing x squared plus 2x minus 8 equals 0, and we're going to see that there's two real solutions. Now remember from section 5.1, the way that we want to graph is by finding negative b over 2a. And remember, that's the axis of symmetry, and that's going to give us the x-coordinate that we need to plug in for our middle x value. So let's go ahead and do that. So we know that a is going to be 1, b is going to be 2, and c is going to be negative 8. And I'm finding that based off of what they gave me. So in front of my x squared, there's going to be a 1, so a is 1. In front of my x, there's a 2, so b is 2. And my regular number without an x is negative 8, so c is negative 8. So if we go ahead and set this up, we're going to have negative 2 over 2 times 1, which is going to give us negative 2 over 2, which is equal to negative 1. So the middle value that we're going to want to use here for our x-coordinate is negative 1. And then I'm just going to choose two values above negative 1 and two values below negative 1. So I'm just going to choose 0 and 1. And I'm going to choose negative 2 and negative 3. Now remember, to get the y values, I need to plug those x values that I've got back into my equation. So for example, on the first one, I'm going to have 1 squared plus 2 times 1 minus 8. And when I evaluate that, I'm going to end up getting negative 5. Same thing for 0. I'm plugging in 0 for the x. So when I evaluate this, and remember, if you're typing this into a calculator, you want to make sure you put parentheses around the things that we're plugging in. I'm going to get negative 8. If I plug in 1, now the negatives is where it's very, very important to put these in parentheses, because negative 1 squared is going to give me positive 1. But if I put negative 1 squared into my calculator without the parentheses, it's going to give me a negative 1. When I evaluate this, I'm going to get negative 9, plugging in negative 2, I'm going to get negative 8, and then of course I'm going to plug in the negative 3, which is going to give me negative 5. So now that I've done this, I'm going to go ahead and go graph. So after I graph my points, we can see that we still don't really know where this graph is going to cross the x-axis. So I'm actually going to add on a couple more points to see if it helps us out. So I'm going to go ahead and add negative 4. And then I'm also going to go ahead and just add 2. And if I evaluate both of these, I'm going to end up getting 0 for both of them. So then if I go ahead and graph those, that is going to help me figure out where is this crossing the x-axis. So I've gone ahead, drawn my points, and I can go ahead and create my parabola based off of this. And remember, our roots or x-intercepts or our solutions is where is that graph crossing the x-axis. And here we can see that it's crossing in two different locations. I'm going to go ahead and circle those so that we can see them. And so our points where it's crossing that x-axis is 2 and negative 4. So we're going to say that x equals 2, x equals negative 4 are the solutions. We could also write these as points, so 2, 0 and negative 4, 0. On the second example, you'll notice that this is not written in standard form. So the first thing we have to do is write this in standard form. So I'm going to go ahead and add my x squared and subtract my 14 to the right-hand side. And then if I do that, I'm going to end up with 0 equals x squared minus 6x plus 9. And again, I want to find that middle value of x to use. So I'm going to use negative b over 2a. And b in this case is negative 6. So I'm going to have negative 6 over 2 times 1, which simplifies to 6 over 2. And 6 over 2 simplifies to 3. So then I'm going to go ahead and use 2 and 1, and 4 and 5. And remember, to get the y values, I'm going to be plugging those x values into my equation. So for 1, I'm going to have 1 squared minus 6 times 1 plus 9. And that's going to give me 4. When I plug in 2, I'm going to get 1. When I plug in 3, I'm going to get 0. When I plug in 4, I'm going to get 1. And when I plug in 5, I'm going to get 4. So let's go ahead and graph those. So if we graph those, we can clearly see that this graph is going to hit the x-axis at one point. And that point is right here. And we see that that value is x equals 3. So we can either say that our solution is x equals 3 or our solution is 3, 0. Either one is okay. In example 3, we're going to be doing the same type of thing. I'm going to go ahead and create my t-chart. So I have x and y. And to figure out that middle value, I'm going to have negative b over 2a. So I'm going to have negative 4 over 2 times 1, which is going to be negative 4 over 2, which is going to be negative 2. So my x values will be negative 2, negative 1, 0, and negative 2, negative 3, negative 4. I'm going to go ahead and take those x values and plug them in. And if I go ahead and plug those in, I'm going to have 0, 6, negative 1, 3, negative 2, 2, negative 3, 3, and negative 4, 6. So I'm going to go ahead and graph those on our graph. So after graphing these, we can see that this actually is never going to hit our x-axis because the very lowest point is right here at negative 2, positive 2, and then we know that because it's going to be a parabola, it's going to go up in both directions and it's never going to come back down to hit this x-axis. So in this case, there's going to be no solution. So far we've seen graphs that are very clear at where they cross the x-axis. Now some graphs that we're going to look at, you're going to have to kind of estimate because it's not going to be super clear. We're still going to graph them the exact same way, but our answer might be a little bit different. So here, I'm going to go ahead, start graphing my normal way. I'm going to create my t-chart, use negative b over 2a. So I'm going to have negative 6 over 2 times 1, which gives me 6 over 2, which gives me 3. So 3 is going to be my middle x value. Then I can use 2, 1, 4, and 5. And if I go and plug those numbers in, I'm going to get 1, negative 1, 2, negative 4, 3, negative 5, 4, negative 4, and 5, negative 1. So I'm going to go ahead and go graph those. Now after I graph those, we can see we could get a little bit more information. So I'm going to go ahead and use 6, and I'm going to go ahead and use 0. And when I plug those in, I'm going to get 4 for both of them. So I'm going to go ahead and go over to my graph and put both of those points on. Okay, so this gives us a pretty basic shape of our parabola, and we can go ahead and connect all of our dots. And here we didn't get a point that gave us a value of 0 for the y. And so we know that it's not going to lie on an exact point. So we want to kind of estimate where our root or our solution is going to be. If we look at both of our areas, we see that it crosses here and here on our graph. So we can kind of see that our first solution is going to be right around 1. And so we could just go ahead and say first solution, and it doesn't really matter which one we look at first, but it's going to be approximately at 1 comma 0, or x equals 1. Now at these, it's not going to be exact because we can't see the exact solution. So if you put, 0.9 or 1.2, that's going to be pretty close as well. So those would be counted as correct. Now on our second one, it looks like we're looking at about 1, 2, 3, 4, 5.2, 5.1. So for our second solution, we can go ahead and say approximately 5.1 comma 0, or x equals 5.1. And if you got something slightly different, if you got 5.5, then that would be fine. I just need to be able to see that your graph matches up with whatever you're telling me the estimated solution is. Now there's homework posted for you for 5.1 and 5.2 already on Canvas. The check your progress on your notes, that's not going to be homework, but if you want extra practice on graphing, you can go ahead and use the check your progress problems that are on the notes.